Hi everyone. Now we are going to be continuing with the second unit. The next topic being UNO programming examples. Okay, so we'll be concentrating in this topic about Arduino UNO microcontroller board, and the Atmega 328 is the one used over there. So please remember, in our particular subject, we are going to be concentrating on the Arduino microcontroller only, and in more specific, we'll be looking into applications related to Arduino UNO microcontroller. Okay. So this is how you will be serially reading some particular data from a particular potentiometer, and this I hope you will be able to guess that you are reading a particular value, and that particular value is through the analog or the digital. I hope you can guess it is the analog pins that are used over here. Okay, so from the analog pin you are reading a particular value of the particular potentiometer over here, where this particular one end of the potentiometer is connected. There are three pins of your potentiometer, one connected to the supply, other connected to the ground, and the one connected to the particular input pin over here. All these analog pins are input pins. I hope you remember they are not output pins as in the case of digital pins over here. So what is happening over here? You are reading the particular value of this particular potentiometer value over here, and that particular value is being read, and it is being used accordingly. So this is a just basic example of a serial read value over here. Okay. So what are you doing over here? You were using pin number A0 over here. So I hope you are able to understand that this particular pin A0 is the one that I'll be using in my program now. Okay. No other pin is being initialized over there, so you can directly come inside. So void setup, you will be initializing your program. You will be having a baud rate because you are using the serial monitor over here. So serial begin is what I'm using, and I'm using a baud rate of 9600 bits per second. And next I'm going to go into my loop condition where my values being read is being iteratively happening again and again. And how much time is it happening once? It is happening once in every 1 microsecond, 1 millisecond. Okay, 1 over here means 1 millisecond, 1000 over here means, as you know, it is 1 second. So void loop, and what am I going to do over here? I am combining two instructions over here in a single line. So I'm creating a integer data type with the name sensor value that would be initialized over here at the top line, but instead of having two separate lines in my program, I'm combining them into one over here where I'm creating a data type sensor value, and that particular value in that particular variable, what am I going to do? I'm going to store the particular real-time data of my potentiometer. How am I going to do that? From my A0 pin, I'm going to read the particular analog value. Okay, so I read the analog value from my pin number A0 over here, and that particular real-time data, and I am going to store it in which variable? I'm going to store it in the variable sensor value over here. Okay, so what am I going to do next? I'm not going to directly put this value into my serial monitor. I'm going to put this variable value into my serial monitor over here. So this sensor value is put into my serial monitor. So that is being provided by serial.println. Okay. So the reason for giving this ln over here is that line by line execution is required over here. So serial.println is given over here of the sensor value here, and every 1 millisecond this real time value is being printed on my particular screen over there. So I hope you're able to understand what is happening in this basic program over here. So next program over here is to blink a particular LED. Okay, so how am I going to blink a particular LED? So you know that you are not LED is a device that goes on and off. Okay, we are just considering the basic on and off condition over here. Blink, we are not going to make it fade. So if you're considering the blink example over here, on and off is the condition. On and off means it is a digital condition over here. If it is a digital condition, you will be using only the digital pins over here for reading, for putting the data on an output pin. Okay, you're not going to read the data from an LED. You will not read the data from the LED over here. You're going to put output onto the LED over here. So when you directly connect the particular pin over here to this particular LED, too much of current will be flowing through the LED, which is a diode, and it will get damaged over here. So instead of that, you will be connecting it in series to a particular resistor over here. So this particular resistor, for example, we consider is a 220 ohm resistor over here. So what you want to do is from pin number 13, which is my output pin over here, I'm connecting it to a resistor. I can use a breadboard over here. From the other end of this 220 ohm resistor, I'm connecting it to the particular anode of my particular LED over here. From the cathode pin of my particular LED, I'm connecting it to ground, making it a loop of current flow. Okay. From this pin number 13, my supply will be provided and it will come all the way to the ground over here. So it is a forward biased diode over here of this particular LED. Okay, you can see the anode on top and the cathode below. Anode is connected to the supply and the cathode is connected to the ground over here. The two arrow marks pointing outside represents that it is an LED, which is emitting light. That is the terminology for LED, light emitting diode. Okay. So I hope you can understand this particular diagram, and from this you will be able to understand that which pin you are being using over here is the pin number 13. Okay, so pin number 13 is what is being used over here. This pin number 13 actually has an inbuilt LED and it has an inbuilt resistor over there also. So you can all see that this LED and the inbuilt LED on your Arduino microcontroller, both of them will be going on and off at the same time. So you can check that also. But anyway, now coming to the program, you are going to use this particular LED built-in, or you can use pin number 13. You can either specify it as pin number 13 because you have a separate LED over here, or if you are using your built-in LED, you can just specify this pin number 13 as LED underscore built-in. Okay, so please understand, only pin number 13 has this built-in LED on your microcontroller. Pin number 0 to 12, they do not have their built-in LEDs available. So if you do not have this LED or the resistor with you for the purpose of verifying the on and off of an LED, you can use this built-in LED over here. If you are using that built-in LED, please remember wherever you have, you will be using the LED built-in over here. If you are using another LED pin, for example, pin to pin number 12 or pin number 9, you are connecting this LED through this resistor. Whichever pin is available that you are using will have to be used in this particular area of LED underscore built-in. Just replace the LED underscore built-in with that particular pin number. So how are you going to execute this program? This program is having the same void setup and void loop in which the pin mode is specified over here. In the pin mode, you're specifying your pin to be the output over here. So you are putting an output from the microcontroller. Okay, so and where are you putting it to? Either to the pin 13 or to the built-in LED built-in. Okay. Next, what is to be repeating again and again? I'm going to turn on and turn off my particular LED. So turning on, I'll be using the terminology high, and turning off, I'll be using the terminology low. So this digital write terminology, we'll be looking into that, how to give a digital write. So you can see the digital write over here, you will specify to which pin number you're writing a particular data. This is your outputting data. Outputting means you're writing a data somewhere. So digital write is to be used over here, not digital read over here. So you're writing a data. Where are you writing it to? You're writing it to pin number 13 or the LED built-in. And what are you putting the data to be? Either 1 or high. Okay, 1 or high means the particular value is going to be a voltage. So which means it is going to turn on the LED. And for how much time is it going to be on? It is going to be on for 1 second. After 1 second, what is going to happen? You're going to digital write this particular value and you're going to check whether it is low there. So you're going to make it low for how much time? You're going to put it low for 1 second over here. So I hope you're able to understand. This is going in a loop again and again. So initially it was high for 1 second, then it becomes low for 1 second. If you are using pin number 9, replace all the LED built-in values over here by pin number 9 over here. And the change in this diagram is that from this pin number 9, you will be connecting it to this resistor over here. From this resistor anode, from this anode cathode, you will be connecting it to ground. That would be the only changes in your diagram. Okay. So that is this basic programming for blinking a particular LED over here. Okay, so you can use another method too. As I told you, if you're using the pin number 13, you can use the pin number 13 over there and you can put the other constraints to be the same. There are no other changes over here. Void setup, pin mode, void loop, digital write. Void setup, pin mode, void loop, digital write. All conditions are the same over here. So delay, you can specify whatever delay you want. Okay, on that. Instead of giving, if you are giving an external LED, replace it by the pin number. If you are using the built-in LED of the Arduino, replaces pin number 13 by the LED underscore built-in. That is the only difference. So I hope you were able to understand both these programs on go. Okay, so this is the simple explanation for that. Okay, so next one is my LED fade in and fade out. This is like PWM, that is pulse width modulation. What is pulse width modulation? In my clock cycle, I'm going to alter the length of my on time and my particular off time. So which means that it is going to be on for some time and it is going to be off for some time. In my normal condition, it will be off or on for some fixed duration. But over here, fading is going to take place. It is going to be fading in or fading out, which means that it is going to initially start glowing and go to its maximum value. From the maximum value, it is going to decrease further and come down to zero all the way, and it is going to happen in a cycle. So how are you going to do that? You're going to do that with this particular microcontroller again. For this, you will be using pin number 9653. Okay, these are the particular PWM pins that are available on the Arduino. Okay, so that you will see that you will be using the LED is connected to pin number 9 over here. Okay, and you're initializing the brightness. Please remember these are not pin numbers. Please remember these are not pin numbers. These are variables that are assigned to this particular value here. Okay, so it's the variable brightness. It is initialized with the value 0. This is fade amount, which is initialized to value 5 over here. This value 9 is the pin number that I'm using for this LED. So the pin number 9, I am now naming it as what? I'm naming it as LED. So wherever you see LED inside, it means that I'm calling pin number 9 over there. You can see it in two places over here. Pin mode LED. I'm declaring my pin, whether it is an input pin or an output pin. You know that I'm using an LED over here. So LED is an output device. So I'm going to initialize this pin number 9 to output. So instead of giving pin mode 9 comma output, which I gave over here 13 comma output, what am I going to do here? I'm just going to give that LED comma output. And another place where I'm going to do, I'm going to write that particular data to the particular LED. I do not have to give pin number 9 over here. Here you give digital write 9 comma height, but here you're going to give analog write and you're going to give the value of the LED over here. So now what is my consideration? As I told you, I'm going to make the value go brighter, go reach the maximum brightness. After it reaches the maximum brightness, the LED should begin to dim in its brightness over there all the way to null or zero or off state. Okay, so it is not going to be a digital quantity, it is going to be an analog quantity over here. So what is the keyword that I'm going to be using over here? The keyword that I'm going to be using is my analog write. Okay, so please remember in my previous program, high or low, 0 or 1, digital constraint only was used over here. But here I'm going to use a particular value that is going to be analog in nature. So it is going to be analog right over here. And what LED, which pin am I going to use? Pin number 9 over here. What is the value that is specified? I cannot predefine it by a value 0, 1, 2 or 3 or some particular value. So I'm going to put a value which is analog in nature and that is going to be determined by these formulas over here. Okay. So LED comma brightness. What do you mean by that brightness? And specifying or what that brightness means. Okay. Brightness is equal to brightness plus fade amount. Okay. What is my initial value of brightness over here? Brightness initial value is 0. And what is my fade amount? The fade amount value is equal to 5. Okay. So 0 plus 5 over here. So initial condition brightness is equal to 0 plus 5, which is 5. If the value of my brightness is equal to 0 or the particular value brightness is equal to 255, what am I going to do? Fade amount is equal to minus fade amount over there. So which means that this is going to be keep on going into a particular loop over here. What am I going to do? If it is my particular condition of the brightness, if it is 0 or if it is 255, what am I going to do? If it is 0, I'm going to keep on adding 55555 all the way to 255. And when it is 255 over there, what am I going to do? I'm going to begin decreasing the particular value over there. Okay. So I'm going to decrease the particular fade amount whenever applicable. Okay. So that depends on that particular condition over here. So this will be keep on increasing every 300 milliseconds. Okay. Sorry, 30 milliseconds over here. So this is what is going to be happening here. So it's actually 300 milliseconds. So I hope you are able to understand this particular condition of my LED fade in and fade out.